So this is just an update for the higher level. Please have a look at the standard level video first. That explains to you just quickly why this actual HB is taking more radio frequencies, and it's doing that because it has far less shielding. All these chlorines are sucking the electrons away, so it's less protected from the external magnetic field, so it takes a stronger radio frequency in order to spin. So that's why that one's further down. Okay, now as I said before, I really want to get away from memorizing. So you could just learn n+1 and Pascal's triangle to number one, work out how many peaks there are, and then if say there's 5 peaks, you can then work out what the strength of those peaks are. Okay, there's 2 problems with that. Number one is when you get to the exam, you're going to forget stuff, and this might be the stuff that you end up forgetting. Number 2, you're not going to have the understanding you need to answer the tricky questions that come up in IB. So make sure you have watched the first video for standard level to make sure you understand which groups are going to be appearing in which areas and be able to predict. And so now I'm just going to talk about how you can work out the number of splits and how you can work out the height of those splits. And I'll just do it with this one here. So what you have here is the HA. That's going to be in a situation where this HB is either going to be up or it's going to be down. And I'll just draw it over here. It's either going to be up or it's going to be down. And there's only 2 choices. So that one's fairly simple. So it must have 2 peaks. Now, if the magnetic field is acting in this direction, then this one here is going to cause the most influence and make the external magnetic field act the strongest. And so this one will have the greatest de-shielding effect, and so this one over here will be the down when this HB is actually spinning in the opposite direction, de-shielding it. Okay, and because that's only 2 situations, they're going to both be of equal size. Next we move to the HB. Now the HB will have these HAs acting in this situation here. So that could be HA1, HA2. So they could be both acting up, which is going to double the strength of the magnetic field. And so that we'll put that as a 1 situation there. And these can then either be, it can then be up and one's down, down and one's up. So that's both ways. So that's 1 situation here. And that is 2 situations here. So we write a 2 there. And then they can be both facing down, which is counter to this magnetic field, so it will actually be the 2 down, and that is 1 situation. Okay, so you can work out how many peaks there are and the strength of those peaks from first principles. And you don't need to memorize that, oh, there's 2 here, n+1 is 2 plus 1 equals 3, and then memorize how Pascal's triangle works. You can know it from first principles. What's the advantage? Well, you've not memorized that, so you're not at risk of forgetting it. And number 2, there are questions in the tests that always ask tricky stuff you've never seen before, such as, you know, what if this is a C and there's a H and there's F's here? Where would you expect that to be? And I would say that would be quite clearly further down, not further up. And video 1 on standard level will explain why that would cause more de-shielding, and so therefore be a downshift. Alright, so I hope that's helpful. If you have any questions, please put them below, and I'll do my best to answer them. Thank you.